this case is pretty cool. This is the Phanteks EX6, and it's completely chambered out, basically. So there's a video card chamber where the video card's just sitting floating. There's no external shell or anything that's missing. This is how the case is designed to be. And we actually, the whole back half of this video, we're going to talk about some of the engineering challenges that Phanteks faced making this, which is some really interesting insight on the factory production side and the tooling, things like that.
It moves the air here away, so it has two functions actually. It cools the VRM and the RAM directly, but it also forms like a thermal wall. I mean, how you say it, an airflow wall.
Yeah.
Against the heat coming up here.
The extra processing for the recessed area is using a similar tool and process as the edges. So the machine does not need to swap tool. It doesn't need to move to a different jig.
Okay, so we're going to talk about some of that in the back half of the video. We brought you this video with our brand new wireframe V2 mouse mat on store.gamersnexus.net, also accompanied by our new Micro Slop t-shirt. These feature a parody Micro Slop logo with a blue screen of death frowny face, warning marks from event viewer, and our rendition of Tux the Penguin hidden away, and of course, Micro Slop. The wireframe V2 mouse mat on the GN store was made by Andrew on the team in Blender, fully 3D modeled, and then represented in a high-quality mouse mat that you see here. The mat can easily accommodate a keyboard and mouse, has fine detail with the city built of wireframe components for the heatsink, RAM, because let's be honest, it's the only place any of us can get any now, and cooling tubes, and we use a matching blue stitching for anti-fray with a blue rubber underside for some unique GN flair. Head to store.gamersaccess.net to support our deep dive, independent research content like this directly. But for the product side, so they've got an EX5, EX6, they're both kind of the same style visually, and Phanteks is sort of building this in a way where it's intended to be performance focused. So the GPU is going to pull its air through the ventilation, the mesh on the bottom, just using its own fans. And then with the mesh on the top in this particular model, the flow through support comes out here, AIOs come out on the side here, and then they've segmented out the CPU into its own chamber. So depending on which case it is, it's either kind of a full glass, a screen, or glass with a hole in it for screens to come out of. And what was interesting talking with Phanteks about the engineering side is you'll see that fan in the back. That is not a mistake, even though that's where the back of the motherboard is. The intent of this fan is to help provide sort of a curtain of air, like a wall, to prevent some of the GPU's exhaust from ending up in the motherboard chamber, this top chamber here, where it'll just sit and bake the VRM. So this has been one of the big challenges with cases like this. Back when Lee and Lee debuted the SUP01, the SUP01, one of our sort of key early criticisms was that the VRM could run kind of hot just because they smash it all down as small as possible, targets an AIO rather than any air, and you can end up with a lack of air movement. So Phanteks, in trying to prevent this problem of the VRM overheating, put a fan on the back side of the board, which actually does, that should significantly help VRM temperatures. You're blowing air right on the back where the MOSFETs are mounted on the reverse side. But then it also helps to just pressurize the chamber, basically, to prevent exhaust air from the GPU from coming into the chamber. So a lot of cool stuff with this. GPU fins these days are typically oriented vertically, which in a layout like this would mean they're going perpendicular to the motherboard. And so you're going to have exhaust going down into the board and exhaust coming out towards, in this case, the glass panel or the aluminum panel on the other, and then there's some with ventilation we'll show also. So that's your air path for the GPU, and basically where it's going to get out is either through this top mesh, through the PCIe holes if it's not using all of the slots, or if they're punctured, and then also through, let's go to one of the screens over here. So there's also on the 10-inch display model here, this ventilation. And so basically they're trying to make it so that these cases are cooling focused, which is interesting, but also not just kind of the standard box. So I guess if you look at case design, broadly speaking, axial fans, they tend to just kind of spray. And a lot of the time the solution to cooling components in the ATX case is, well, what if we just kind of shoot it air all over the place? They're trying to chamber it in a way where it's more focused. It looks cool. It's definitely interesting. This is an aluminum panel model. The steel panel model is cheaper. It's missing some of the fine detail, like here, for example, on the chamfering, but price point starts at $110 for the steel model, the EX5, And this is 160, well, not this with the screen, but the cheaper version of the EX6 is 160. It goes up to $330 with the screen and the light bar and everything else all included. They're playing around with some panel coloring for the GPU chamber, anodizing the aluminum different colors. Really, the case to me is most interesting because it is in one way creating an artificial restriction on how you build the computer, in that you're shortening your options here for coolers unless you do the option with the glass cutout, but you're not going to do a tower cooler in a case like this. It is, however, more kind of intentional, I guess, in what you do put in there. So I'm really curious from a thermal perspective how it performs. The fan on the back, which we'll talk about in the second half of this video, I thought was kind of brilliant in that the accidental solution to the obvious problem of heat accumulating in this top compartment is, rather than just using the fan to move the air, you're kind of using it to pressurize it and keep air out. So I thought that was kind of cool. But that is the EX5 and 6, though. We have a lot to talk about for the making of it, and I guess a couple more quick specs, but they're going to have options with an AIO built in. And so the 110 base EX5 goes up to 160, so it's an extra $50 to do a 360 AIO built into it. That has a rotary fitting on the top to sort of force the tube on the cleanest possible path through this chamber that way. And then the other tube just shoots right out the side of the radiator and into the CPU chamber for the case. So $50 increase for a 360 is not bad. I guess you maybe get some of that on cutting down on packaging, things like that. But it's when I was talking to Phanteks, they were saying, this is our way of coping with the current environment where people are pressured by RAM prices and GPU prices now to basically try and bring the cost down elsewhere in the build so that people can use that to subsidize what they're going to spend on their RAM. So pretty cool stuff, though. Let's jump over to the interview and the discussion for the rest of it. All right, so now we are joined by Tenzin and Mankin for talking about some of the actual production side challenges, which is pretty interesting.
Yeah, these are early prototypes,
okay,
because still so much has changed. Overall, you recognize them, of course, but internally, nothing has stayed the same. So then, we will call it prototype, even handmade, right?
Yeah, well, I mean, I see you were telling me that here in Taiwan, the rust has accumulated in just 2 days.
Yeah, this is 2 days. We brought them over from Netherlands, where we are located, and they were looking fine. And 2 days ago, we pulled them out of the box, and now we got this nice
patina.
No, now it's color edition.
Yeah, right. The Noctua edition.
Yes.
What do you? Let's do a really high level. Can you just quickly point out a couple of things on the case that were particularly difficult, or like for example, we were looking at this before we started filming, and I asked you, was this curve a huge pain in the ass to make? And you said yes.
Well, it's difficult. In the end, this is the one they can make, right? It has to do a lot with the mesh, right? Mm-hmm. Because mesh, especially for this concept, is so important. So we needed to push the limit for mesh. It needs to be as open as possible to give the GPU, for example, or the CPU as much fresh air directly to its own cooler. Mm. And that also at the same time makes it very weak, right? Because you're cutting away so much of the material. So we need to bring back that strength again, and that you can do either by increasing the thickness, which makes it basically impossible to punch, or you need to do it by shape. And then you need to find a shape that brings a strength to the mesh, but it doesn't deform it and break it at corners.
Right.
So doing corners is difficult, but at the same time you need them to bring back the strength into the panel.
Yeah, that makes sense.
Right? And you can show, in the end, you can just lift the whole thing by the mesh. This was actually the first full prototype we made. Before this, it was all, cut up pieces, cardboard, foam panels and such. So this was the first time also for us that we saw the whole thing come to life, which is pretty cool. It's a cool moment. And I think this really shows the breakdown of the product, right? And it's like a chassis inside out. Instead of a big box around it, we actually started out with like a skeleton, similar to like some tall buildings, right? Where the whole structure or the strength comes from the central column, right? Where the elevators are. So similar to here, like this is the mainboard compartment. This needs to be really strong. This is what's carrying all of the components, right? So that's like opposite approach as to a standard box chassis. Right?
Typically, do you get the strength more from the corners on the
Yeah,
outsides?
yeah. So, and then the edge profiling that goes all along all of the edges, that's where really the strengths come from. And then you hang all the hardware inside.
Right.
Roughly. So we needed to get that strength back, even though it's so slim, so radically different from the box. And then we really needed to optimize for that very direct performance, very direct airflow. So you can see all these components, like these mesh components. Normally, it depends how far back you go. Like first mesh was just a huge sheet of mesh. And I think you can remember, and even some cases you can still see it. They just put a piece of mesh that's very flimsy inside a bezel. Yeah. And that's how it's held together, because that's the easiest to make, right? And then over the years, they came up with new solutions to make, let's say, a single panel, a mesh panel, but then it has solid edges.
Right.
Right? They're able to make this now pretty reliably. And so now the panel on its own doesn't need an extra bezel, right? But you do have these straight solid edges. That was the limitation. And for this design, because all the shapes are so radically different, it's not all rectangles anymore, right? So we really needed to take another step. Otherwise, it wouldn't have worked good enough, right? We would have been stuck like midway the development process. And I think here you can see our first attempt. You can see it's better than that one, but you still have rectangular shapes that we can decide like, okay, don't cut here, right? But here they cut over the edge because it's all rectangular shapes.
Is it punched and then bent, I guess? Is that the process? Okay.
Yes. But then the surface that they decide to punch or not to punch, they're all rectangular. And that caused some problems. So it causes too much resistance in certain areas because it's fully blocked off, right?
Do you have to do it in different stages in the factory? Like in other words, do you have to, when you're punching this many holes, does it have to be done in groups?
Yes.
So as not to work?
Yes, but it's also you have to do it spread out. So you basically cannot punch two holes right next to each other at the same time. It does go through a continuous process of the machine, so it kind of looks like the whole thing is punched at the same time, but it does it in many separate steps. So like it's punching like in with distance in between them, punching them, right? And then as you have maybe 10 steps punched, then all of the holes are punched. Right. Okay. And then with this project, the difficulty is to decide exactly which hole you do want to punch and which one you don't, to optimize the airflow and to bring back the strength. Right. For example, the mesh is weak because the rectangular it now covers this corner, so now this corner is weak. Okay. Right. So that would not be strong enough to hold all of your hardware components. Right. So that's something I think took half of our development time to get that to work. And I think in the end result you can see really well where we get to decide exactly, we can follow any corner or rounded corner or chamfer exactly, because they are now able kind of to program the machine precisely, so decide exactly per hole which one to punch or not.
Okay. Is the testing more build and assemble usability testing, or is it like thermal testing? Or?
Mainly in this case we did a lot of thermal testing because of the different shape of the case actually. Like normally, I mean, you have a box and you can rely on the fans. You can see how much airflow goes through the fans and how much you can get into the case, right? But this is really different from what we're used to be. So especially for this case, we did a lot of thermal testing. Just to see what works, what doesn't work.
We had the idea, right, but we didn't, I mean, the idea sounded nice, but we had no idea if it really worked.
Yeah, we can refer to something that has been done in the future, in the past, I mean. And,
What, was there anything you were working on here where you made a significant change because the thermal results weren't what you wanted?
Yes.
Okay. Any examples?
More than one.
More than one. Yeah.
Should we open one up?
Sure.
Show some of those details.
Well, as you can see, in this case, we like some direct airflow. So we, instead of like in the opposite of regular cases, all the components have their own compartments. Right. So they all get that direct airflow from, like GPU got direct airflow from the bottom and exhaust from the top. and we were quite happy with it, with the result of this. And then the AO got its own airflow pad, and the PSU, of course.
Right.
But then there was one problem with the motherboard here, because I mean, as you can see here, the GPU is a little bit of overlap with the motherboard.
Yeah,
right?
yeah.
So there's some heat of the GPU going inside the case,
Right.
which heats the motherboard, and its components like the VRM
I guess
and the
also,
RAM.
if most GPUs are vertical fins, right? So it's going to blow air
Yeah,
down.
they blow. Yeah.
Okay.
So we were happy with this setup with the airflow, but we discovered a problem here. So we needed a solution to fix this. Well, as I said, we tried a lot of testing. So in the end, we found out that if we add a fan here behind the motherboard, blowing cool air in, it really helps to move the hot, still temperature air here that builds up here actually.
It just
it's not
stops
moving.
it from sitting, I guess.
Yeah, it moves the air here away. So it has two functions actually. It cools the VRM and the RAM directly, but it also forms like a thermal wall. I mean how you say it, an airflow wall.
Yeah.
Against the heat coming up here. So so there's heat coming up
It's
here,
funny,
and
yeah.
we have a.
It's kind of like
form like a wall.
current in a river, right?
Yeah,
It's
yeah.
preventing
So everything
it, yeah.
will be blown out in that way. So
Uh-huh.
will not the heat will not affect the motherboard anymore.
Right. Funny.
Yeah.
Yeah. Okay.
So-
And it's surprising because we went from oh damn we have a problem to like damn this works really well. So it's like the VRM and RAM temperatures are actually better than like a standard
It
mesh.
should help the
chassis.
VRM a lot. I
Yeah,
guess,
it helps
right?
really a lot.
It
Yeah.
worked surprisingly well.
We also tried I mean, when we were testing, we also tried the fan in the opposite direction.
Uh-huh.
Like maybe we thought, okay, if we try
Try
to
to
pull the
pull.
air away, maybe
Yeah.
that works better. But it really turns out just to blow it against the hot air that's coming from the GPU. Yeah, it works.
I guess
like,
it kind of
wonders.
makes sense. Yeah, I mean, it's
Yeah, after you think about it,
right.
it does.
If
but,
you're pressurizing the compartment, right, to stop hot air coming in.
Yeah.
So
But I mean, if you look at it at the first sight, it's really weird because the fan is so close to the rear of the motherboard. But actually, the fans blows the air to the side.
Yeah.
It swings it to the
Yeah.
side, right? So yeah, we have all those openings here, where the motherboard is also lifted, of course, where all the air can go to the front, and then it pushes the air
Okay.
away. Yeah.
cool. Yeah, that's pretty interesting.
Yeah, I mean, because this case doesn't really rely on fans, on fan cooling, right? So the direct airflow is really important. So we made a lot of like improvements to get as much airflow as possible with this case. So on this model, you already see there are much more holes in here.
Right.
So you can see, okay,
Some large holes.
Yeah, we like to cut as much restrictive parts away to get the airflow as good as possible. We improved the mesh, of course, and if you can, like we even it on the AO bracket, we thought because we have a 360 frame fan, we just removed these parts too.
Okay.
Even as you can see here, they're not here.
Right.
To remove even the
Just get some
slightest
blockage
resistance.
out, right? Yeah. I mean, it's in theory those shouldn't block a lot, but they do a little bit.
They do a little bit,
Yeah.
and yeah, since we really want to get everything out of this case, so there are small adjustments which are, we discovered when we developed this case.
We also had some surprises, right, with the mesh experiments that we did, because this is the EX6, right, and that's the EX5 prototype.
Yeah.
Because you would think, more is better.
Yeah. Yeah. So
Right.
for the GPU, we thought maybe it helps, like the exhaust of the GPU is on the side, right?
Yeah.
So if we add mesh here, it will probably help to get.
I mean,
the
that
heat
was
away.
going to be my question for this one, because if the fins are oriented vertically, it seems like the air would want to come out here.
Yeah, I want to come out there.
Yeah.
So, but we couldn't do it with aluminum because then the cost will be too high for the case, right?
Okay, yeah.
I mean, it's hard to do. So, okay, then we tried. Okay, we do it on steel and see how it goes, and it turns out this really helps.
Okay.
But then we still want to do it on this case. So we had to find a different solution. So that's where this part comes in. So it's like a rubber strip.
Oh, okay, yeah.
Let me get this off first.
That's pretty cool.
So this strip, it will be attached in, other way around. It will be attached in here. And this helps to divide the intake and the exhaust chamber of the GPU. And yeah, well, like this is also we had a lot of testing. We found out if it worked or not, and it turns out this saved like the same amount of temperature with the mesh.
The idea being to stop recirculation of the
Yeah,
hot
stop
areas?
recirculation.
Yeah.
I mean, if you don't do this, the air will come out here, right, on the side, and then the hot air gets in again. And
do you happen to
keeps it
remember, like,
warm.
roughly what kind of difference you were seeing?
I think it was about 1.5 Celsius.
Okay, I mean that's a lot for a GPU.
Yeah.
I think our entire GP range, top to bottom on the case charts, is not more than 10 degrees. So 1.5's a lot. Yeah.
So so that's why
cool.
we how we fix this.
And then I guess you don't bother with that here, right? Because it's just a punch through.
That's a punch through.
The separator, I mean, you don't need the separator on this one.
No.
So is that was that? I guess the reason you can't punch holes through for aluminum, is it just cost of the manufacturing process?
It's because it's 3 millimeters thick,
it's
like
not-
really thick aluminum.
So is
And
that just
it's
like a-
CNC cut. If you want a CNC cut mesh,
Yeah.
you'll be paying a lot. So that's
And I guess the reason for that, CNC relatively slow versus like
Very
a punch,
slow.
right? Yeah.
Yes.
And if you have to punch something like this, is it just a ginormous machine, or is it?
well, again, it is a big machine for sure, but you're not, when you're punching mesh, you're not punching each hole in one go.
Right.
It is like 3, 4, or
Stages.
5 steps. Yeah, you cannot punch 2 holes very close together at the same time. You need to split that up into steps.
So for aluminum, plus the aluminum material just gets to be too much, I guess.
For aluminum and 3 millimeter, it also pulls the material down, so it's going to look.
Okay.
Yeah, it's not going to look the
Got
best.
it. Yeah. Yeah, this is cool. So obviously, I haven't seen this without the GPU container, shroud off yet.
Well,
but-
interesting about this is to mention is we work a lot on the GPU bracket actually.
Okay.
So as you can see, it's screwed down on the side and even on top. So this really makes it really sturdy, because we think it's really important to hold the GPU securely.
Right.
So yeah, you can just lift it here. It's really sturdy now.
Yeah.
And it's even good enough for shipping. So we spend a lot of time to develop this. So how can we make it as sturdy as possible?
Triangles are
Yeah,
magic,
it
right?
always works. But we also wanted to support smaller GPUs. But in the market nowadays, even smaller GPUs are really expensive.
Even a small GPU.
Even a small
probably,
GPU. Yeah. So we developed this thing to be able to turn around. So you can also, I mean, you can see a lot of holes in here, attachment holes. So even if you attach it like that, it can even support the smaller GPU lengths, before the motherboard.
Cool.
Actually. Yeah.
Yeah.
Well, what we can point out here is that you can see the CNC. I think it's really nice CNC
Like the
cutouts here,
chamfer.
chamfers in here for the buttons and for the USB ports.
What when you make a decision to add a small detail like that, right? Like this is, I think until you pointed out, I wouldn't have thought a whole lot about that, but CNC is a different machine and an extra step.
Yeah.
I'm sure that adds a lot of complexity every time you do it.
It adds cost, but it also comes with like some rewards, because it looks good, and the reason why it looks good is even if you see it like this, you can really see the thickness of the aluminum, so you see what you pay for.
Yeah.
So for another example for that is this like this cutout. I mean, on a steel one we just have a straight line, right? And here we chose to do like a small detail, but with this issue you can really see the thickness here of the material, and also on top. And for that we don't need it, right? Because it's just a thinner material. So yeah, that's how we make some design choices.
What kind of cost impacts does something like that have? I mean, like, is it where if you add a chamfer like that versus you don't, is that a decision where you're like, this might change our MSRP, or is it?
Yeah, so that's different, right? Because it depends on the exact shape of the detail that you want to do. And in this case, the extra processing for the recessed area is using a similar tool and process as the edges. So the machine does not need to swap tool. It doesn't need to move to a different jig.
Okay.
So that, you could say it adds some detail. Yes, you'll pay for it a little bit, but it's not that much, and it does bring a lot more character to the product.
Who normally helps with figuring that out? So, like, knowing that you're already using this tool and this machine obviously is valuable to know, because now you know you can get more fancy with it, right?
Yes.
Is that is that just you guys know that from experience? Is that the factories kind of telling you? Or?
There's really a lot of back and forth.
Yeah.
Okay.
That's a lot of back and forth, and it's like almost like a game because both sides want to make it better for them.
Yeah.
They also are happy to take on the challenge also, but it's
Right.
like not too much challenge because then it's going to be my headache.
Right.
So it's like at the same time it's like a pushback. So we're pushing each other to find a different way to reach something sometimes.
Right.
And sometimes it's the other way, saying no, I really I love this. I want to do this. And that can come from both sides. It can come from a supplier, the factory, from us. We're both like giving pushback and also pushing the other one to do more at the same time.
Yeah.
And I think this is a good example of that, right? And once you decided to use a certain tool, then everybody should think about, okay, what else can we do with it to get the most out of it
Right.
as well.
Is there, if you had to point to like one thing for the case, was there any one thing that almost didn't make it into the final that was like you're kind of able to figure it out at the end or whatever? You know what I mean? Like, what are some features of this that were almost too challenging to go to production with?
Well, basically the whole thing was like the whole thing, like does it even work?
Yeah.
But because that's why we got with we got the right side fan, we call it, right? That really was a make it or break it.
Yeah.
And
if we couldn't fix it, it would be a big problem.
Yeah, then we say, okay, we're gonna start over, do something else.
So let's say you couldn't fix it. Let's say this wasn't an option for some reason.
Yeah.
How many months of work at that point are you abandoning? You know?
That was
Couple.
6, 7.
Yeah.
Wow,
It was
okay.
pretty long time already.
Six
Yeah.
months,
Yeah.
for sure, definitely.
Do you ever get that far along and realize it's not going to work?
Yeah,
as a
Yes.
product?
Yeah,
Yeah.
that happened before.
Can even go further. I mean,
Yeah.
if it's the best decision, then you should always make the decision, no matter where you're at.
Right.
I mean, you should of course then learn from it, so next time you'll recognize that earlier.
Yeah.
But if it's the right decision, it's the right decision.
Yeah, even if you're like working 6 months on a project and you know it will go into a dead end, you can try to revive it, but you better just stop it, right? And just,
Right.
Yeah.
just
And
find
you should
another
not
way.
think about it being a waste, because we've also had this where a project got cancelled, we worked it out, like we're very happy with it, got cancelled, okay, and then 1 or 2 years later, a different project came up and you said, oh, wait a minute. That's kind of similar. So we just made some changes. I was like, here it is. And we saved like 3-4 months of development.
We do that all the time on the video side,
Yeah.
where we'll kind of abandon a project partway through. It's like, I don't know, it's not really working. You know, then you get later, it's like, we can kind of pull pieces of these projects.
exactly.
Well, that's actually for the cases too. Like sometimes you can just put like a lighting solution or something. We found it for a case and then we just put it in a new case.
Or even just the knowledge,
Yeah.
something you
Knowledge,
learned, you can directly apply.
Right.
Yeah.
Anything else on here, like specifically you wanted to point out as challenges or stuff you feel like you want people to recognize how difficult something was to do?
Well, I think maybe it's one interesting is that we, as Martin just mentioned, right, the GPU mesh helped performance. Then we found a different way to do the same thing with the rubber strip.
Oh, yeah.
But at that point, we were also thinking like, okay, more mesh is more better, right? Well, let's try it. Let's reduce the temperature as much as we can. So the EX5, this particular prototype has a mesh at the top side for the motherboard, right? Which was
up here.
an issue at a certain stage of the development. And actually the temperature goes up.
Okay.
So more mesh is not always better.
I mean, I guess also maybe that makes sense. Does it go up with this fan in the back?
Yeah.
Okay.
So you lose the air actually. The
You
fresh
lose-
air you get from
yeah.
the top, it will be gone.
Right, so you lose your wall effect.
Yeah.
You're actually amplifying the
Right.
exhaust of your GPU through the motherboard.
you're
Pressure systems, right?
Yeah,
That's
yeah.
cool. Yeah.
Yeah.
I see pressure
So
systems.
more mesh is not always better.
Yeah. No, we've definitely seen that in testing as well.
Yeah.
Especially if you start considering recirculation and stuff like that. Very cool. I mean, I think that probably, unless you had any other pieces here you wanted to point out, but that probably wraps up the case coverage. So
those were the main things, I think.
yeah, thank you both for joining
Thank you.
and for all of the detailed information. As always, subscribe for more. We'll have testing in as soon as cases are ready, and we'll see you all next time.